Milinji both for inviting me and having me here to have this interaction, I would say. And also thank you very much for this very elaborate introduction. I did not expect that. But in a nutshell, I'm a person who look forward to work and continuously learning in the field of energy efficiency. As I understand, this forum is for I also see the list of attendees, and I see all of the people who are having good amount of experience, and they come from diverse backgrounds. So I take this opportunity, to share what I have been doing for last something 15 odd years, and also what I am right now doing, in the field of ESCO. So this is, as I said, I take this as an opportunity for sharing my experience. I also, invite all of you to contribute in the topic for the benefit of all. So whenever and wherever you feel, we need not to segregate this between the delivery and then question and answer. So whenever you feel you can contribute or you want to discuss a particular point in detail, you can intervene and we can discuss that. I would just request Bhavanaji to have this, interaction open for all. So anybody can unmute the mic and discuss. That would be great.
Yeah, everyone can unmute their mic and talk whenever it is required, or else they can raise a hand and.
Yeah, that's great. So with this, I'm sharing my screen now. And let me go to the topic of discussion. Just confirm me if my screen is visible and the presentation is visible.
Yes, it is.
Okay, fine. Thank you. Thank you very much. So the topic of discussion today is role of an ESCO, or in general ESCOs, in achieving net zero. So these are all topics that we will go through today. We will understand what is climate change and net zero, how is it perceived, how energy efficiency can be a pragmatic approach to address this, how ESCOs facilitate in energy efficiency projects and to make the development more sustainable. What are the stages of ESCO projects? How M&V plays an important role in making ESCO projects successful, and typical do's and don'ts. So many of the parts. Okay. So many of these. Somebody has unmuted mic.
Can you please all mute your mics? Otherwise, I'll have to.
Okay. Yeah. In general, keep your mics mute. Whenever you want to speak, you can unmute, and that would be good. Otherwise, it would be a noise. Thank you. Thank you all for this. Okay. So let us start with this. So as I was just saying, most of the things I have picked up from my work as it is, and some of the things which I have organized from repeated references. So that is how I would be discussing this topic. But at any given point in time, we can discuss, and I would again invite all of you to contribute. So it would help everybody to enhance the understanding of the topic. Climate change and net zero, how to arrest global warming. So this is a typical graph which is pretty well known, particularly to the people who are working in this field for many years. So climate change, as it is typically referred to, the long-term shifts in temperature and weather patterns. And if we see, let me just take the pointer. Okay. So these valleys, if we see, these are the glacial periods, as we can say, and these peaks, as we see, are the interglacial periods. So there had been warming and cooling period, and at any given point in time, this is a scale on y-axis. We can see the CO2 concentration in the atmosphere. So till 1958, never reached 300 ppm of CO2 in the atmosphere. This is average concentration in the atmosphere. And then onwards, as the industrial activities started making their impact, we see it has crossed 300 ppm, and it has also shown impact on a rise in the temperature. Okay. So, and also it has associated weather patterns, changes in the weather patterns. So this has been a steep rise since then, and that is what we can see. And use of energy, use of resources contribute to most part of this rise. Because till here we see there are other things which are contributing to increase in the CO2 levels and decrease in. But here onwards, it is our use of resources, human use of resources, and more importantly, the energy that is causing this. This graph shows us the variation in the temperature. And from 1850, we can see the temperature going above average. So this is called as pre-industrial reference temperature. Okay. And from then we see the rise in temperature. So average rise in temperature. And this average rise in temperature or long-term rise in temperature is being termed as global warming. So our globe is getting warmer and warmer every year. Now, what is the target? So as a whole, as a globe, we are targeting to arrest this increase in temperature to 1.5 degrees Celsius as compared to the pre-industrial era. Now, why 1.5 degree? So the scientists predict that any rise above 1.5 degrees Celsius would be irreversible. Okay, and it will be totally uncontrolled. That would be very much harmful for the very much existence of humankind as such. Okay, and overall biodiversity. So it has to be arrested up to 1.5 degrees Celsius from the point of pre-industrial temperature. Now, how to do that? So it can be done by arresting or reducing global carbon dioxide emissions. The temperature rise is attributed to the increase in carbon dioxide. As the carbon dioxide increases, it captures, it makes the global warmer. If we can control the CO2 levels, we can control the rise in temperature. The typical concerns are like hotter temperature every year is getting hotter and hotter. There are more severe storms, increased droughts and floods. There are areas which never have seen the droughts are observing the droughts. The areas which have seen less rains are observing floods, warming of oceans and rising of the sea level. That is also causing loss in the species, particularly the aquatic species. There are then invited health risks and poverty and displacement. So the areas which are facing extreme climate events, they are forcing migration, and this displacement or the migration is causing poverty and then also inviting the health issues. So that is how this is directly making an impact, and this impact is visible since 1980. Who can fix it? So all the players, all the stakeholders, and everybody needs to work towards it. So for that matter, governments can make laws, regulations that can help in fixing the situation. Businesses can conduct their activities in sustainable way, in eco-friendly way, so that they reduce their part of emissions. Civil society as such, the people, the intellectual groups can create pressure groups make the governments and the regulators work towards sustainability. Each individual like you and me can make choices towards more and more sustainable life and reduce our own footprint. And we here, all people who are discussing, the distinguished community of energy professionals, I would say, can equip ourselves, increase our skills, have our own capabilities to ensure judicious use and use of resources and energy. Now, when I say ensure, it is not only limited to ourselves, but to our clients, to forward and backward linkage of our clients, and to a society at large. So we have, it's not our privilege, but it's our responsibility to act proactively towards this. The solution, and the solution is sustainability. Typically, sustainable development as it is defined is a development that meets the needs of the present without compromising the ability of future generations to meet their own needs. It is very clear definition, nothing philosophical, very much clear definition. Sustenance and prosperity of human societies need consumption of energy in some or the other way. And the results, this very much, requirement is resulting in emissions. And these emissions beyond the limit are causing threat and challenging the very existence of us. And if we see the emissions, the contribution to the emissions by different sectors, the industries are causing it highest. It is 38%, followed by buildings, 30%, transportation 25%, and others 7%. So this is the overall, summary of emissions that we receive from different sectors. And what is the solution? So there are solutions being discussed, and most recent discussion that is in effect is the Paris Agreement in 2015, where 191 countries, all the countries have submitted nationally determined contributions, which is over covering almost 90% of CO2 emissions. So if we see here, 90% of the emissions are covered by first, and this is nationally determined contributions. 40% of the countries have ratified these NDCs into law. So they have made their own law. So these are 40% countries, and that is covering almost 70% of emissions. So I'm sorry, this is about it. 40% countries and covering 40% of emissions, and 25% of the countries have pledged net zero targets. That is covering 70% of emissions. So broadly, if we have to understand, this is how we can look at it. So almost 58 countries have proposed or have net zero targets in discussion. 9 countries have declarations and pledges. Okay, and this this is, so 9 plus 58 total countries, we can say, are thinking, and some of them have made the pledge. 52 countries have made policy documents, so they have strategized how to attain their own net zero targets. And 26 countries, or 26, these are actually 41 countries. So one EU is considered as group of countries. So 25 plus EU have made law to attain their net zero target. Now, which are these countries? So some of the names we can see here. By 2030, Maldives would attain a net zero target, and it is made a law. Okay, so they have made a law in their country. By 2035, Finland would attain. By 2040, Austria and Ireland is looking forward to attain the net zero target. By 45, Germany and Sweden is going to attain the target. By 2050, EU member countries and USA has targeted to attain net zero. By 2060, China, Russia, Saudi Arabia, Ukraine, these are the major countries who have decided and have made policy document to attain net zero target. By 2070, India has targeted to attain net zero. There are other countries. I have not considered any countries from proposed or discussion stage. So this is in a nutshell how world is looking forward to attain the net zero. Over the period, total globe has to attain the net zero, so we can restrict the climate change. We can restrict the global temperature rise to the desired level. This is another graphical representation. So how different technologies can help. So we can see energy efficiency, renewable energy plays important role in reducing the emissions and attaining the net zero target. Going forward, let us discuss more about energy efficiency. So which appears to be a very pragmatic approach. As we have discussed, for the for basic development, for availing the basic the facilities for respectful livelihood, we need to consume resources and energy. So we cannot say that let us not consume energy and save or reduce the emissions. We have to consume, but that can be done in more efficient way. So energy efficiency and energy management is the more pragmatic approach towards making our development more and more sustainable. So energy efficiency, as IEA, Energy Efficiency Association, puts it, is the first fuel of energy transition. The benefits of energy efficiency and energy management can be listed like cost savings, community benefits, environmental benefits, resilience and reliability, okay, to adapt to the changes, and of course the health benefits. How to facilitate the energy efficiency? And here it needs both technical as well as financial capabilities. In the technical capabilities, there should be people who can do the assessments or audits in simple terms, choose the right technologies for energy efficient operations, and implement and realize these benefits. So this is these are the technical capabilities that we need to have to move on this path. We should have an infrastructure which facilitates the delivery of these technologies. We should have risks mitigation plan. If we implement the technologies, they should not derail. If we choose this path, that path should be on the track. So we should have the risk mitigation facility and plan for it. We should ensure the benefits. To ensure the benefits, we should have tools and techniques in place that the implemented measures are working and their benefits are getting realized. And facilitate the funding. This is the most important thing. So for doing anything, we need the funding, and this funding should be facilitated. So there are ways and means to facilitate this. Traditionally, the organizations or the countries, the governments can spend their own money, their own funds, which is called as equity funding. The organizations or the governments can borrow money for third party financing, like banks or financial institutions. The technologies can be leased. There can be true lease or capital lease, just type of lease. So at any given point in time, the technology or the equipment, if is going to be owned by the user, then it will be a capital lease. Otherwise, it is true lease. This has been the traditional way of availing the finance. There had been alternative ways of financing, like energy performance contracting. That is what we are going to discuss today by ESCOs. And there is again a new innovation called as efficiency as a service, EaaS. We will see briefly what does that mean as well. So ESCOs and the performance contracting availed by ESCOs. It is a tool to facilitate energy efficiency for sustainable development. ESCO is a company that offers technical capabilities for energy services, which may include implementing energy efficiency projects on turnkey basis. So ESCOs actually bring both technical capabilities as well as funding too. Okay, funding for the projects. So ESCO provides an innovative financing model for upscaling the energy efficiency. ESCO guarantees the energy savings. The remunerations of ESCO is directly dependent on the energy savings that is achieved. Now it depends upon the type of the contract. We will see the different types, but there can be energy performance contract, or there can be guaranteed savings contract, or shared saving model as well. But based on the contract, ESCO gets its own remuneration, and ESCO can finance the operation of an energy system by providing energy saving guarantees. Did somebody say something? Okay. ESCO accepts some degree of risks on both technical as well as financial part, and ESCO gets its payment delivered based on the energy cost saving, more importantly. So there are different ways in which the countries are approaching towards energy efficiency. So some of the countries have energy efficiency obligations. For all of us, we know in India, we have Perform, Achieve and Trade scheme, which is kind of energy obligation scheme. Okay. So the organizations, the designated consumers in particular, have obligations to achieve targeted energy efficiencies. Okay. So these are called as energy efficiency obligations. And some countries go with ESCO route. Okay. If we see, UK has energy company obligations, or it is also called as ESOS, energy saving obligation scheme. France has the white certificate scheme. Italy has energy efficiency certificate scheme. Denmark has similar obligations. India, as we discussed, has PAT scheme, Perform, Achieve and Trade scheme. Germany has energy performance contracting EPC model. In general, EU has EU energy regulation. Okay, and within that regulation, each country has its own model to comply with this regulation. There is energy saving performance contract way, which is being practiced in United States. Actually, it's been the ESCO has basically emerged in USA, and since 60s or 70s, I think we can trace back the roots of ESCO in US. So there are, South Korea and Brazil. So there are different models. If we go to the history, in US, typically, I think in 70s, when the world was experiencing the oil shock, first oil shock, the ESCO has started gaining shape. So there used to be basically the energy has become costlier, and then organizations were forced in a way to reduce their energy cost. And for achieving this, different companies or organizations, basically small companies, or you can say a small branch of a company, big company, started offering these kind of solutions to save energy. And initially, people may not believe, the organizations not used to believe that the solution that is being provided would actually benefit them in saving the energy. And because of this disbelief, the companies which are offering these solutions started offering that we will implement the solution, and we will, charge only if there is saving. And then the shared saving model was put in place. So if there is saving, 50% of that or 70% of that would be shared with the company which is putting the technology. And that is how energy service companies have started. So these kind of contracts started taking shape, and over the period it has become well-known mechanism. So a different part of the world operates in different way. For example, in Asia, mostly it is industries which are dominant sector, which are going for this kind of ESCO contracts. Whereas in Northern American countries and parts of Europe, it's been buildings, which are the major, facilities going for ESCOs. So if we see here, this is better way to understand this. So there are different countries, and we can see who are the people who are going with the ESCO route, or which kind of sector is going for the ESCO route. For example, in India, we can find the major ESCO contracts in industry. This purple color is for industry. Whereas Canada, we can see the non-residential buildings, so office buildings and commercial buildings, they are going majority for the ESCO contracts. In US, we find combination of buildings, non-residential and residential buildings. So mostly in US, it is, I would say, the government facilities, the federal government facilities, which are going in big way for ESCO. For all the modifications they are being done, they are done through ESCO route. So they achieve their modification targets, the renovation target, upgradation target. At the same time, the cost is optimized because it is done through ESCO route. So the upgradations, the modifications are done in energy efficient way, and it is win-win for both the user, the entity, as well as for the company which is implementing the solution. The other map, we see how much is the participation of private and public. Okay. So there are countries where public money is put to use for the ESCOs, whereas
Kindly mute your mic.
okay, fine. I thought somebody speaking. All right. So in the energy performance contract, we see, so typically there are two ways in which ESCO contracts can be done. One is energy performance contract, wherein this is a new way or creative way of financing, where capital improvement that allows the funding for energy upgrades from the cost reduction. So basically what happens is, in this contract, this explains it better. So this is EPC, where the facility or the host actually gets funding from financial institutions based on the proposal that is given by ESCO. Okay, so ESCO guarantees, ESCO offers, makes energy saving proposal. It guarantees the savings. Okay, and this proposal is presented to the financial institutions, which ultimately funds the project to the entity. Okay, so in a way, we can see the financial risk is on the entity, but this is offloaded to ESCO again by the guarantees in the saving. If there is no guarantee, there are ways in which the ESCO has to recover the savings. So it can be by penalties, or it can be by guaranteed bank guarantees. So the tool can vary, but the financial part is taken care by the financial institution, and the financial risk ultimately is offloaded to the ESCO. This is energy performance contract. And as against, there is shared saving contract, where ESCO facilitates the funds. So ESCO can have its own fund, or it can get loan from the funding agencies or financial institutions. So it offers complete package to the facility, to the host facility, or to the entity. Okay, so it offers the solution as well as funding. So in a way, it puts the project by its own cost and recovers the capital from the savings. And the shared saving model can be tailored based on the understanding. So it can be something like 30-70, 50-50, 60-40 kind of savings. So based on the project proposal and the acceptability, the attractiveness, the proportion is decided. So these are broadly two ways in which the contract can work, either guaranteed saving or a shared saving model. There is a new way called as energy as a or efficiency as a service, energy efficiency as a service, EAAS. Okay. So in this case, in any previous case, as we have seen, the project is owned by the entity, the end customer. But in case of energy efficiency as a service, the project is not owned by the entity, but it is owned by the service provider. For example, an ESCO. So if an ESCO offers this kind of EAAS, energy efficiency as a service, to an entity, then it installs the project, the equipment or the retrofit, whatever it is, and it offers it as a service. For example, a company or an organization which needs steam. Okay, so instead of putting new boiler, ESCO will put a new boiler for that entity, and ESCO will offer them steam at competitive price. So for example, the organization is already spending some X dollars. ESCO can offer something like at 0.8x of dollars per ton of steam. Okay, and that is how the ESCO owns, operates the energy efficiency solution and charges the competitive rate to the entity. So entity gets the service at competitive rate without headache of maintaining it, and also it is not having that asset on its books. Whereas ESCO owns the equipment, so it has full control on its operation, so it can operate it in the best efficient way that is possible, and also gets the benefit of economy, benefit of efficiency both. So that is how both are getting the benefit of it. So this is typically how it can look. So there is a customer, there is a ESCO, and the ESCO can offer EAAS model to the customer. Okay. Apart from that, ESCO also can have an EPC contract for other solutions. So some solutions are given in EAS way, some solutions are given in EPC way. So this is how it can work. The combination can be worked. Okay. So this is how we can see the difference between ESCO and EAS. So in case of ESCO, the capital is put either by ESCO or by customer. As we have seen, it can be guaranteed saving model or it can be shared saving model. In case of EAS, the total capital is paid by ESCO only. Okay, so the end customer doesn't pay anything. When it comes to the asset, it is, in case of ESCO, it is not on the balance sheet of ESCO, but it is on the balance sheet of the end customer. When it comes to the ownership of the equipment by the customer, yes, in case of ESCO, the ownership is by the customer, and in case of EAS, the ownership is not by the customer, but it is by the ESCO or the service provider, whoever it is. The risks, in case of EAS, there is no risk on the customer. Okay, all the risk is borne by the service provider. In case of flexibility to the to add the or retrofit during the contract period, for example, let us say energy efficient pumps are provided as EAAS, energy efficiency as a service. Then in that case, the ESCO can decide, let us increase the savings by putting VFD on it. Okay, this can happen in EAAS. But in case of ESCO, the ESCO contract is frozen by end of the project, and then it continues for the ESCO period, the contract period, whatever it is. It can be 5 years, 7 years, 10 years, whatever it is. So there is no retrofit possibility unless and until the contract is renewed. Okay, within the same contract, there is no retrofit possible. So these are finer details, and based on the suitability, one can choose whether to go with ESCO contract or any variety of the ESCO contract, can be guaranteed saving or shared saving model, or go with energy efficiency as a service model. When it comes to ESCO, there are different challenges. Okay. There are risks and there are associated challenges. Typically, in the developing countries, ESCO faces more challenges because of lack of or availability of weak legal framework. Mostly now, even in India, if we see, we operate, the ESCO contracts are mostly administered or monitored by typical contract law. Okay, largely it is the contract law which administers it. There are ESCOs being registered under BEE, but very limited way in which these ESCOs operate. So EESL operates as super ESCO, but other ESCOs are operating in very limited way. The reason is maybe there is no very well established framework for ESCO operation. There is a perception of very high risk. Going into the ESCO contract is perceived to be very risky because these contracts are long term and there are multiple parties involved. The risks and responsibilities are not very clear, so nobody wants to touch the risk. Okay, to get into that risk, and this issue creates a fear. Typically, when it comes to financing, the banks or the financial institutions perceive this as high risk proposal, and they would not offer, or they would be reluctant to offer the financial support in kind of for this kind of proposals. Lack of credibility. Basically, the ESCOs concepts are new, the companies coming in the field are new, which may not have a very good track record or long-term track record. They may have capabilities, but since there is no track record, so credibility is has a question. Sometimes there are unreasonable expectations from the customer. Okay, so ESCO will do everything, and I don't have to do from tomorrow onwards. I just have to take care of my operations. Is a kind of expectation which actually is not good for ESCO projects. So, for example, any energy efficiency project that is being implemented as an ESCO, under ESCO, since it is being operated within the premises of the end customer, its maintenance, its upkeep also is an important part of it. So O&M and M&V, we will come to that, but are important part of it. And if they are not done diligently, any energy efficiency project will not, deliver the or retain the savings as it is expected. So there are risks. There are technical risks, there are operational risks, and also there are financial risks, because these projects are for long-term projects, more than 5 years, 10 years projects. Weak financials of ESCOs again make an issue, because as we see, these are long-term contracts. ESCOs should have working capital and healthy finances over the period, okay, to sustain, because there can be time, there can be period, for any reason the savings are not achieved, and the revenues are stretched, and there can be another year when there are good savings and there are more benefits. So there should be resilience from ESCO point of view, and more importantly, it's funding point of view to absorb these kind of shocks. These are the typical risks through which one has to think as an ESCO. Let me just see how is the time now. Okay, fine. We are almost nearing 1 hour, but I will take a few more minutes. Maybe we can extend by 10 or 15 minutes.
No issue.
Okay. So there are risks on the financial front as well as operational and technical front and performance front. So on the financial front, interest rate may vary over the period. Energy prices may vary. So in the developing countries, energy prices are increased the pace of increase is more or less same. Sometimes the pace can vary. So that is a risk. The construction cost. So by the time the ESCO contract is finalized and the construction is being, taken place, if the duration is, more than desired, the construction starts something like 1 year after the contract is finalized, the cost may differ by then, or some sudden events. For example, some war happens in some part of the world and it increases, prices for a specific commodity. For example, recently we have seen the increase in semiconductor price. Everything has gone costly based on semiconductors. So something like that can happen, and that is a risk that has to be considered. M&V, we will come to discuss M&V measurement and verification, but the confidence on M&V, its protocol, the savings, how the savings will be calculated, does matter. If there is low confidence, it's a risk. Delays can cause the risk, financial risk. Major changes in the facility is a big risk to happen. So suddenly there is a capacity addition in the facility, and it causes deterioration in the savings. So it's not deterioration in the savings, but overall energy bills would increase and the savings would not be visible. Okay, so that is a risk, and we should understand that risk. And there are ways and means to mitigate that, but that should be taken in account. There are operational risks. Operating hours can change, load can change. Weather has its own way. If typically something is sensitive to the weather, sensitive to the temperature, ambient temperature. So typically HVAC units would consume more in the summers and consume less in the winter. Heating, if it is heating based facility, then it will consume more in winter and less in the summer. So that has to be considered, adjusted. User participation is important. So for example, if there are practices set, if there are automation is done and there are set points to be observed, monitored, set points to be varied based on the season, then user participation in that case is important. If it is not done well as prescribed, as desired, savings will deteriorate. The project will not perform as desired. Other performance risks include equipment performance. Equipment deteriorates over the period. If it is, a solution is combined of more than one things put together, then life of all the equipment, all the components does matter. If there are some components which need replenishment, replacement, they should be done. For example, filters, bearings, the things which needs, they have their own life, which can be less than the life of total equipment or total solution. So that cycle has to be understood and to be maintained. Operations as per SOPs or OCPs, operation control procedures, to be maintained. Preventive maintenance, or more importantly, condition-based maintenance has to be there. And equipment repair and replacement cycles are to be maintained. Mitigate the risk, there is a tool called energy saving insurances. So there are these kind of insurances available for ESCOs to reduce uncertainty associated with performance of energy efficiency projects. So there are two types of energy saving insurances available or offered. So one is for technical, and another is for credit risk or funding risk, financial risk. Or the same insurance has two components to mitigate the technical risk as well as the financial risk. So technical risk, for example, for any reason the energy saving equipment doesn't perform. So the risk is mitigated by the insurance. Of course, the premium is paid and it is taken care. The financial risk, for any reason, the finances are not well, the customer is not paying to the ESCO, then that risk is taken care by that insurance. So the loss is recovered. So this is how the ESCO challenges and the risks needs to be mitigated. Let us understand how the ESCO goes ahead. So there is typical way in which the ESCO contract needs to be built. Excuse me. So there is very preliminary first stage assessment. Okay, it is also called as walkthrough assessment. Okay, which is very high level assessment. So this is to understand what is the potential and what are the possible projects that can happen in a particular facility, in a particular setup. So it can be categorized like class A or category A, B, C, or 1, 2, 3, anything. For example, let us say A project, which have good efficiency potential and the efficiency is comparatively very less. So these are very low payback period projects. We can say financials work very well in this kind of projects. Type B can be moderate efficiency projects with some medium amount of investment. So something like 1 to 2 years or 3 years payback period. Can be category C projects where there is low energy efficiency available, low saving potential available, but investment required is high. So this categorization helps in prioritizing the projects or identifying the good mix of projects. So sometimes the energy efficiency projects, as we are discussing in the context of net zero. So it's not always for saving the energy cost and making profits or increasing the profits, but this is more for attending the emission targets and making the business, the operations more and more sustainable. So we cannot always go for lucrative projects. Sometimes we also have to go for less lucrative project. And then in that case, with the limited financial capabilities available or limited resources available, either we have to prioritize the projects or we have to identify the good mix. So we can identify some projects from class A, some from B, some from C, and every year we can have some phase-wise implementation. So broadly, the first level or preliminary assessment will just give us a probing of what can be the projects and what can be ABC projects. The next thing is to conduct a detailed energy audit and identify actually the projects. This is more concrete way of conceptualizing the projects. So it is also called as detailed energy audits generally when it comes to industrial audits, industrial projects. In case of building projects, ASHRAE has its own classification. So it is called as ASHRAE level 2 audit. Okay. So where actually the energy audit team spends time in the facility. It conducts the measurements, logs the energy data, and also conducts some trials. And based on that, the energy saving measures or energy saving projects are identified, like 1, 2, 3, 4, 5 projects. Their savings are quantified, and roughly what can be the investment. So those numbers are identified, and then some simple financial tools like metrics, like simple payback period, are used to understand which are lucrative projects, which are less lucrative projects. Okay, so it prepares a reference list with a prioritized or phase-wise implementation. So this is more concrete way to go ahead with. Okay, once let us say we have the detailed energy audit done and we have this reference list, now there can be a discussion between the entity and the ESCO that which are the priorities with which the entity wants to go ahead for the implementation. Okay, so out of, let us say, this 10 list of 10 projects, the entity says, or both entity and ESCO agrees that we will go ahead with this 7 projects or 5 projects. Okay, so that these projects are identified, and now at this stage actually there is something called investment grade audit that is conducted, or in case of buildings it is called as ASHRAE level 3 audit. Okay, Now this audit is for detailing. Okay, broadly the savings are identified. Okay, based on the spot measurements and some logging. This logging in case of detailed energy audit is limited to 1 day, 2 day, not more than that. But in case of investment grade audit, now these identified projects are taken for detailed assessment. Now here typically the team spends more time. These audits are of for more duration, something like 1 month, 2 months. It can be up to 6 months under observation. So these audits, the important part of that is observe different scenarios of operation, log the energy data or other important parameters like temperature, pressure, maybe observe the ambient conditions over the period, correlate this data with all the parameters, and then identify what are the parameters that affect the energy consumption. So this gives a good understanding of the the facility, the equipment, the systems, they are operational, and then the energy conservation measure is clearly identified. It is technically clearly defined. The savings are more concrete. The savings can be guaranteed, okay, by end of this kind of exercise. And the energy conservation measure is worked out in detail with its BOQ. So for example, a detailed energy audit for that matter, the stage 2 audit would just say go for replacement of pumps with energy efficient pumps, and then there is some payback period of, let us say, 2 years. But here in this case of investment grade audit, it would be like what is the existing pump? Let us say it is 50 HP pump, or it is something like 37 kW pump, has to be replaced with another 25 kW pump with so and so head and so flow. Okay, with or without VFD, it is integrated VFD or separate VFD. Okay, and then whether the existing, for example, setup, the existing foundation would work for the new pump or it needs a different foundation. So that level of detailing needs to be done, when it is investment grade audit. That is done. So equally, even the financial line also, the same detailing is done. So what is the amount of investment required? How much is the investment for material? How much is for the the labor of it? How much is the investment or the budget for O&M of it? How much is the budget for M&V? Okay, so that level of detailing is done, and if there are any replacements required during the life of the equipment or life of the energy conservation measure, then what are those replacement? What can be its cost? Okay, and it's based on the duration or based on the time period when these replacements are required, what is its impact today? So based on its net present value, how much is actually the benefit of the project? Okay, so beyond a simple payback period, there is advanced level of financial metric that is used. It can be IRR or it can be NPV, and that that kind of financial detailing is also done. And finally, all that is put together in a contract or in a proposal, which is going to be a contract, which is going to be an ESCO contract. Okay, so this proposal typically has savings. This proposal has the BOQ that is to be done, which has clear plan of implementation of the energy conservation measure. This proposal has also a clear plan of how to evaluate the savings, how to determine the savings. Okay, so this is called as measurement and verification. So how the measurement and verification is going to be conducted to determine the savings year on year, month on month. And then what are the risks, what are the responsibilities, what are the guaranteed savings? So this is very detailed working of the proposal, which is called as ESCO or energy performance project, energy performance proposal or energy performance contract, as it is called as. it is called as EPC, or it is also called as ESPC, Energy Saving Performance Contract. So outcome of this kind of detailed study or investment grade audit is actually a clear ESCO project, ESPC. Now, once the ESPC or EPC, energy performance contract, is identified, signed, agreed, okay, with its M&V plan and responsibilities, okay, risks and responsibilities, then there is implementation phase. So after signing this contract, the ESCO implements the project, okay. So whatever it is, replacement or retrofit or upgradation or modification. So for example, if it is building and there is building management system already in place, which can be upgraded, there can be retrofits on the utility side. For example, pumps can be retrofitted with VFD, or they can be replaced with efficient pumps. Chillers can be replaced with efficient chillers. In case of industries, let us say boilers are replaced with efficient boilers, or compressors technology is improved. Instead of old, let us say, reciprocating pump compressors, new screw compressors which are more efficient are put. So whatever it is, so that implementation has to be done at this stage by the ESCO. So ESCO should be technically capable of getting this implementation done. ESCO may not implement or execute this on itself. Maybe ESCO can deploy further other teams, or directly it can be done by OEMs or system integrators. But the technical responsibility of delivering the project as agreed is on the ESCO. Okay. Now, once the system, the energy conservation project is implemented, there is a baseline data that needs to be collected. So not actually when it is implemented, but during the implementation or before the implementation, there should be credible baseline data that is collected. So sometimes the energy bills, for example, electricity bills or the oil bill or gas bill, whatever it is, itself is a good data for the baseline period. Okay, so just collect the past year data or past 3 years data, and if the operations are same in the similar manner, then that itself is a baseline. Sometimes the projects are being done only for the limited part of the facility. Okay, so then the total electricity bill or total oil bill or gas bill may not serve as a baseline data. Then in that case, there should be good amount of energy data logging done. Okay, credible amount of energy data logging should be done. So something like for 3 months or 4 months or 6 months, which covers all the scenarios. So that much period data should be logged, collected, and that will form the baseline. Okay, and after forming of the baseline and agreeing of the baseline, actually the implementation will take place, and the ESCO will execute the project at this stage. Once the project is executed, then the performance period starts. So after executing the energy conservation project, the performance period would include largely the measurement and verification of the savings and operation and maintenance of the energy conservation measure. Now, based on the contract, the operation and maintenance can be responsibility of the ESCO or cannot be. So based on the responsibility matrix, it would depend. So here, if we see this, this is very indicative graph. So here is a baseline period which is passed. This is the implementation, installation of the project, and here is the performance period or reporting period, you can see. So here is a baseline which is generally adjusted for any variations as compared to the baseline period, and then there is actual consumption, and difference between this adjusted baseline and actual consumption is called as savings. So this is how the savings are determined. Now, why the baseline is adjusted? Because not all the parameters are same in the performance period. For example, the production varies. Now the production X becomes 1.5x in the performance period. So the energy consumption is going to increase. So this additional 0.5x or 50% production needs to be adjusted, okay, in the baseline. So if 100 units consume so much energy, the 150 units would have consumed so much energy. So that is the adjustment in the baseline. And as against that projected energy consumption, how much is the actual energy consumption? Is this actual energy. And between this adjusted baseline and actual energy consumption is the saving. Okay. So these adjustments, there are, there is something called as routine adjustment and there is something called as static adjustment. So non-routine adjustment. So routine adjustment is for predicted, changes. So something like changes in the production, changes in the weather, changes in the ambient conditions is part of routine adjustment. But as we discussed, any expansion would be non-routine adjustment. Any addition in the working would be non-routine adjustment. You predict some savings for an institution to operate at, 8 hours a day. And suddenly that institute is operating for 2 shifts, 16 hours a day. They are conducting night classes. Okay. Then that adjustment is non-routine adjustment. Okay. So these adjustments are done and then savings are determined. So this is, this is part of measurement and verification. And for that, a clear understanding of baseline and clear understanding of measurement and verification protocol needs to be done. And here we come to the discussion of M&V. So this M&V helps in continuous monitoring of performance of the energy conservation measure. It also helps in, periodic monthly or monthly saving and assessment of savings and review of the savings. In case the savings are not as predicted, the course correction can be done or a feedback can be taken. Actually, why is it not happening? Maybe there are some scenarios which were not predicted and they are happening. In that case, we need to go for either adjustments of the baseline or we need to go for course correction in the working of the ECM, energy conservation measure. Okay, so by this way, we ensure that there is desired saving, the benefits are ensured. Okay, and this is the benefit of having a right M&V plan in place. Okay, so let us discuss a little more about M&V. So apart from any, all other things, all other technical and financial risks that we discussed in previous sections, M&V becomes very important, and it actually proves the cornerstone of the energy saving contract, energy performance contract. So a good M&V plan actually establishes credibility for the proposal. Okay, so if you go with perfect M&V plan, right model, clearly defined baseline and clearly defined savings with different scenarios of operation, expected variations, and in case of non-routine variations, static adjustments as it is typically called, any changes, typically in the facilities or for unforeseen reasons, there is a space in the plan how the savings would be determined. Then that a solid M&V plan helps the project to be more and more credible, and that can give edge. It can also give good confidence to the funding agencies, so the finances are available. A good M&V plan helps in documenting the financial transactions. So how much is the saving, how much is the benefits, how much is the returns to the ESCO, how much is the returns to the end customer, the entity itself. So those are documented well. M&V helps in retaining and increasing the energy savings. Okay, since it is done in a periodic way, maybe every week or every month or every quarter, whatever it is, the decided period. So the savings are ensured. If the savings are not there, the root cause is identified. It is addressed, and again the savings are retained. So that is more important part of it. It also improves the engineering design, facility operations, and maintenance. Since it is being monitored very closely, the maintenance is taken care, the operations are taken care. It is ensured that the operations are as per desired while putting the energy conservation measure. It also helps to manage the budgets and also regulatory reporting. So in case of any reporting, for example, in India, for the designated consumers, there is M&V audit every year to report the savings. There can be audits required for emission reduction targets. Now I am lead assessor for this ESOS program in UK. So these organizations need this ESOS report to be submitted every year. And the submissions are not in terms of always energy and monetary saving is part of it, but how much CO2 emissions are reduced. That is another important part of it. So any regulatory program needs this reporting, and M&V helps in achieving that, making that reporting diligently. M&V activities or measurement and verification activities, typically if we have to do good M&V, either the existing meters should be well calibrated and maintained, or if required, new meters can be put. Okay. So as we were discussing, it cannot be always, the total facility may not be under M&V, but only the part where we are putting the energy conservation measure is under M&V. So that part should have adequate metering for all the necessary parameters. So energy, power is one part of it. Its output also needs measurement. So for example, if it is chiller plant, how much BTUs or how much tons of cooling it is delivered needs to be monitored regularly. If it is compressed air, what is the pressure that is being maintained? If it is boiler, how much is the steam that is delivered? At what parameters, at what pressure and temperature it is delivered? So that has to be monitored. Data gathering and screening is part of it. There should be some good mechanism to gather the data. Either put logs or download the data, hook the meters with your laptop, or get it downloaded with let us say every month or every 3 months, or have these meters communicable and have some IoT based platform like energy monitoring system, and have this data always downloaded with its history, for desired duration. Development of computation method and acceptable estimations. Okay, so with the M&V, so you should have the possible scenarios understood, and so it is also called as modeling. So with using some technique, it can be regression technique or it can be any other technique, we can develop mathematical models to understand and to accommodate different scenarios. Okay, so in a particular scenario, how much would be the energy saving in baseline condition and how much is the actual energy saving? So that has to be very well established. So the keen observations during the baseline period helps to develop a good sturdy model for determining the savings in the performance period. Computation and measurement with the measured data. So continuous measured data is important. No savings should be based on any assumption. Okay, the savings has to be on the measured data and known information. Okay, sometimes some data like operating hours may not be measured, but that information should be known. Okay, and it should be agreed that every day for example, lamps are operated 12 hours a day. It should be agreed. It should be known. It can be measured as well, but it has to be correctly monitored. So M&V activities also include good reporting and quality assurance of the data, and this can be done by third-party verification as well. Okay, so sometimes there are third-party M&V audits which are expected. Now, for any systems, for example, the well-known system of PAD, there is M&V audit done by the well-known, as it is called as energy auditing agencies. Even if it is ISO 50001 implementation, that is energy management system implementation, there is third-party M&V expected. Okay, so there is some M&V cycle that is expected. So it has to be done. Now, when we go for measurement and verification, there are different protocols. Okay, I will not go to the details, but there are something like called as option A, option B, option C, and option D protocols. So these are defined by IPMVP, okay, International Performance Measurement and Verification Protocol, IPMVP. Okay, and then there are IPMVP qualified auditors to do that. So there is CMVP, one certification run by AEE now, called as Certified M&V Professional. There is also another certification run by PMVA, known as PMVA by EVO, Efficiency Verification Organization, Valuation Organization. So this PMVA is performance verification. I think PMVA. I'm not able to recollect its full form. Yeah, but it is comparable to CMVP. So earlier it used to be only one certification, but most recently both these organizations are running it separately with different names. So these professionals are there to help plan a good M&V plan and conduct that M&V on regular interval. So based on the projects, one has to identify which option one has to go. So there is something called as option A, which is where only key parameters are measured. For example, lighting, only some sample lights, spot measurements are done for their power consumption, and based on that, the energy savings is determined. The previous lights were, let us say, for example, FTLs of 56 kW, and new lights are, let us say, LEDs of, let us say, 15 kW, delivering similar illumination. So the difference between this, so even the previous lamp is also measured. It may not be always consuming 56, it can be consuming anything between 50 to 60. And average number is taken by identifying number of samples. So there is way, how much sample to be taken. So there is scientific way, there is something called as uncertainty measurement done, and based on that, the sample is identified. That much amount of sample is measured for both baseline installations as well as new installations. And based on this difference and number of operating hours, the saving is determined. So only one parameter is measured, that is power. Operating hours are taken from the records and the savings are determined. This is option A. In option B, all parameters we should measure, because always it may not be as simple as light. Okay, for lights, for constant speed operating motors, option A works. But for variable speed motors, for variable delivery equipment like chillers, for variable delivery equipment like boilers, option A may not work. So then in that case, we need to measure all the parameters. Okay, we need to measure the power consumption, we need to measure the demand side. Okay, and based on the demand side, how much is the power consumption, that correlation has to be established, and based on that correlation, the saving need to be established. So that is option B. Sometimes we have multiple projects implemented in same facility. Okay, and then one project affect the performance of other project. For example, if we do lighting replacement and also we do some ECMs on HVAC side. So if the lightings are replaced with efficient lights, the building heating affects. Okay, so all the light that is all the power that is consumed for lighting ultimately gets converted to heat in that particular zone. So if the lighting consumption has reduced, the heating has also reduced. Okay, so the cooling demand is reduced in case of hotter seasons or hotter regions, and heating demand is increased in case of colder regions or colder seasons, right? So this is an interactive effect. This is called as interactive effect. So more than one ECMs in a same zone has interactive effect on each other. Then in that case, we cannot measure the performance of one ECM itself. Okay, so we cannot isolate that equipment or that ECM. Then we have to go for whole facility level of measurement, and then we go for whole facility options like option C or option D. Okay, so these are quick I would say the explanations for option C and option D, or for all kind of these options. In case of option C, we do mostly we should go with the utility meter, or it can be sub-metering covering all the energy consumption of that area. Okay. In case of option D, if the baseline data is not available, a calibrated simulation or a model is developed. So there are softwares which are used for this. In case of buildings, it is EQuest, or there is energy saving softwares available. In case of equipment, there are equipment based. So there are something called HAP for HVAC systems. There are some softwares available for heat exchangers. There are some softwares available for boilers. So those softwares are used for option D or calibrated models. So when the baseline data is not available, if you are going for altogether new projects, you will use option D. Sometimes we may find the projects with combination of these options. Okay, so I have seen and I've been working on the projects where we have used option A and B, we have used option A and C, we have used option A, B, and C all. Okay, we have used option D and B. So all that variety now I'm handling. So there can be more than one options in a in a single project. As we increase more variety, there is increased complexity, and we should have capability to deal with that complexity. That is the important thing. And to have that, the M&V plan should be very much clear. Okay, so M&V plans, I mean, we should start making the M&V plan since the beginning of the conceptualization. So at the walkthrough itself, we should have some conceptualization for what can be the M&V plan if we go for these projects. Okay, by the time we finish our investment grade audit, so we discussed walkthrough, we discussed detail audit, and then we discussed IGA, investment grade audit. So by the time we finish the investment grade audit, the M&V plan should be finalized with what options we are going, what kind of meters we are going to use, what parameters we are going to capture, at what frequency we are going to do this analysis, what kind of review we should be doing. Okay, while doing this, all the stakeholders should be involved in this. So we should involve the entity, we should involve the financial institution, we should involve the end user. Sometimes the entity is different and end user is different, because government decides to implement a project in its, let us say, some 100 buildings. So the building users are different. So all of them should be involved in the project. Okay, including the OEM part. So all of them should be part of making decision of M&V plan, or this M&V plan should be circulated to all of them. So anybody has any concerns should be raised, flagged off, and should be addressed while finalizing the M&V. Okay, it should be generally the inherent part of the ESPC. So this is a typical, we go with development of ESPC with M&V, and we finalize the M&V.
Yeah.
So we are end of this now. So this is one of the projects that we are working on, where we can see this is baseline, adjusted baseline. This is actual consumption. Sorry, this is actual consumption, the orange color, and these are the savings. The gray color is the savings. This project is, the target is achievement of 42% of savings, and for last 3 years, this project is achieving the savings more than that is predicted. So this is how typically the M&V helps. Now the last bit of the discussion, I hope I would just spend 5 minutes on this. Do's and don'ts for the ESCO projects. The typical do's, the savings should be estimated in conservative way. Okay. We should leave some buffer for unknown things, unknown variables. I know, as we go conservative on the savings, the financial metrics may work in adverse way, but within the given limit, we should have a conservative estimations of the savings. One should choose appropriate M&V option. So if it is constant operating equipment, it should be option A. If it is variable operating equipment, it should be option B. If there are multiple ESMs working together, it should be option C. So right M&V plan, right M&V option should be chosen. An ESCO should ensure back-to-back guarantees and maintenance contracts from the OEMs, because ultimately the technical risk is borne by ESCO. Okay, so anything goes wrong, ESCO should not get the hit of it. ESCO should ensure compatibility in case of retrofit and upgrading projects. So for example, old projects, old equipment, if we are going to upgrade, if we are going to touch them, we should understand the compatibility. For example, putting chiller plant manager on the chillers, and chillers are something like 20-year-old, which don't have communication infrastructure with it. Okay, it doesn't have the communication card for that matter, or the protocol is not compatible, then it may not work. Okay, so either that equipment should be able to make it compatible, so that cost has to be considered, or in case of uncompatible equipment, we should think of replacing the equipment and then thinking of the benefits. For example, putting VFDs on the pumps. If the pumps are more than 20-year-old, first they may not be compatible. They may not be, the insulation may not be compatible. Even if the pumps are F-class insulation, the motors are F-class insulation, because they are old enough, they may not absorb the issue with the VFDs and they can get burned. So better to replace them and then consider the savings with that capex. Okay, so that compatibility has to be understood. Keep communication channel open with the end user and the entity, because ESCO contracts are long-term contracts. So there should be good, healthy communication, and good M&V plan actually helps this, good, healthy communication. There should be very clearly defined risk and responsibility metrics. Okay, so in case of what risk, who is responsible for what? Okay, so for example, the entity should be responsible to declare its operating hours. Okay, if entity doesn't declare it, the ownership goes to entity, the issue goes to entity, the penalty goes to entity. That kind of risk and responsibility should be identified and very well discussed and should be part of the contract. There are some don'ts, like do not overcommit, as we discussed regarding the savings. To make the project attractive, it should not be unnecessarily overcommitted, either savings or the performance. Do not take technical risk. For example, don't go for the first installation of the new technology that is in the market. Okay, you don't know the performance, you don't know its working, you don't understand its working principle, and then we take it as for take it for ESCO project, then it can be a big risk. Okay, it can be a big technical risk. Do not retrofit or equipment which will end their life before the ESCO contract period. So ESCO contract is 10 years and we are putting something which has less than 10 years equipment. Either we should not go for it, or if we go, then we should understand its replacement cycle, and that should be accommodated in the contract. Okay, so its financial impact is absorbed, and then the savings are identified, the benefits are identified, then it is good to go. Do not exclude the cost of additional BOQ necessary to make the ECM work. Yeah, so we think of upgradation of let us say, for example, we think of upgradation of BMS system, and we think of putting some new sensors in the field. and we accommodate for the sensor cost. But if we forget, or if we do not, take consideration the cost of its communication, its cabling, its first fix, second fix, then that is the additional cost that is necessary to make it work. If it is not considered in the estimation and in the budgeting, it would be additional cost. The project may go in loss. If it is not done, the project is not going to give any savings. So all that, additional BOQ has to be considered well in advance. So a good amount of engineering goes in, identifying the ESCO projects, and that has to be done very diligently. And then in that case, the ESCO does work well. So yeah, I believe that is the end of the discussion from my side. I know we already have overrun a lot, so still, if we can spend some time, if there is any point to be discussed, any question answers, or anybody wants to contribute, add to the discussion, we can have some time.
Yeah, thank you, Mr. Gadikar. It was quite an elaborate presentation. And what I realize is that we can have one more session on M&V especially. I mean, that was very interesting. And before we go on to questions, let me acknowledge presence of Mr. Sameer Javade, who is Associate Vice President for International Membership of AEE chapter, AEE. And we welcome you, Mr. Sameer. Welcome to AEE Western India chapter webinar series. Yeah. So,
hello, Mr. Sameer, how are you? We have been discussing on emails and sometimes on some group meetings, but it's good to see you here.
Yes. Yeah. Nice to have you on our forum. And yeah, like now the floor is open for the questions.
I see 2 questions put here. Okay, fine. 2 chats.
No. Yeah, anybody having any questions can put up in the chat box, or you can, even everyone is unmuted also. So you can speak up, like if you have questions. We will have for 5 more minutes.
I can see some very well-known names. So
yes, so this forum, as you can see, is quite popular now, and many good professionals are joining this, and we are really happy to have you all on this forum, and look forward for more participation from your side. So if anyone is willing for any event presentations, also you can contact us, and we can arrange for that. Yeah, I cannot see any questions.
okay.
Yeah.
So anyway, it was nice interaction, I believe.
Yes, definitely.
Yeah.
I mean, about the ESCOs, so many things are clear, and many new things also we came to know, like this energy efficiency as a service. That was a new concept, and especially M&V part was covered very well and very elaborately. So I hope this will be very useful for all the participants here. And the recording of the session will be available on YouTube and by evening today itself. So our YouTube channel is AEE Western India. So you can log on to our YouTube for our previous recordings also. And we hope that you keep on attending our sessions and kindly keep giving your feedbacks also, so that we can make this forum more and more useful for all the energy efficiency professionals. Thank you. Thank you all for being a regular attendees also. There are many who are attending this forum regularly. Thank you so much. Thank you, Vinayji. Thanks for your contribution to this forum. Yeah.
Thank you all. Thank you very much. Good time. Take care.